Okay, the following graph shows the median earnings of females from 2005 to 2009 in constant 2009 dollars. Okay, how is the bar graph misleading? What does it seem to convey? So, if you have a first look at it, it seems that the earnings have risen rapidly in 2007, and they are much higher compared to 2006. But if you read the numbers in 2006, it was something between 34,500 and 35,000, whereas in 2007 it was little above 36,000. So it's not as rapid a rise as it looks at first sight. And the reason is that this is an unusual graph where instead of starting from zero, it's starting from some other values. And there's nothing wrong with that. You can start a graph anywhere. But then what that means is you have to be very careful in making conclusions, since some of the things which we are used to because of graphs starting from zero are no longer holding. So normally if a graph would start from zero and you would see this shape, then you would say that this is a manifold increase. But in this situation, as the numbers are telling us, it's only a slight increase. And let's see, the vertical axis starts at 34,500 instead of zero. Yeah, that's where it was starting. This makes where the bars should start unclear. No, there's nothing unclear about it. It's just that you have to be careful. Okay, so vertical axis starts at this. This tends to indicate that the median earnings for females changed at a faster rate than they actually did. Yeah, that's true. Okay, redraw the graph so that it's not misleading. So let's see, how do we redraw it? Okay. In 2005, the earning was a little over 35,000. This could be it. This is not it because this is only 30,000. This is not it. And this could be it. So it's either A or D. And let's see, what other difference do we have? Let's look at the second year. In 2006, it was 35,000 in this one. But now in 2006, it should be under 35,000, which is probably the case in D if you pop this out. So yeah, it's no, even here it's not under 35,000. So even D is not right then. So okay, let's look at it again. So in 2005, it should be above 35,000. In 2006, it should be below 35,000. So which one is saying that? Okay, this one, A is below 35,000. Let's look at A. Yeah, so A is below 35,000 in 2006 and it's above 35,000 in 2005. So A is the right one. So the graph, the true graph seems to convey that the earnings were almost uniform. They were almost the same because the vertical heights are nearly the same all the years. Indicates remained they were not completely unchanged, but they remained fairly constant. So remember, we had this situation early on. Early on, we learned that statistics doesn't give 100% answers to situations. So anytime an answer is saying something to be exact, where versus another answer which is saying approximate or about, you always go for the about. So it's not completely unchanged. It's fairly constant, but in this particular case, we can also see from the graph that it did change a little bit, but so you can't say that they were completely unchanged. fairly constant is the better thing. Okay, so a newspaper article claimed that the afternoon hours were the worst in terms of robberies and provided the graph to the right to support his claim. So yes, the afternoon hours, the 12 p.m. to 6 p.m., do have the highest frequency of robberies, but if you look carefully, this is a 6-hour window, whereas all others are 3-hour windows. So actually here, although we have fewer robberies during from 6 to 9 p.m., but that's only a 3-hour window as opposed to 12 p.m. to 6 p.m. So here all the bars are of the same color, and the color has nothing to do with it. So this is a misleading graph because they've drawn the widths to be the same, and yet this is a 6-hour width sitting among 3-hour widths. So not all the time intervals are the same size. Redistributing the time intervals so that they're the same size may lead to a different picture, yeah. Okay. The following table shows grades for a term paper in English. Table is incomplete. Use the information to complete it. So first of all, the total relative frequency, as we learned earlier, has to be 100%. So once we fill that in, we see a relationship because the total is 50 and the total frequency is 100%. So we see that the right column is double of the left column. So if this is 6, this is going to be double of 6, that's 12. And then if this is 10, this is going to be half of 10, that's going to be double of 10, that's going to be 20. Now this is 28 and the left column has to be half of the right column, so that'd be 14. And this is 16, so this will be 8. And then we don't know anything in the first row, but this, for example, the total needs to add to 50. So this is 6 plus 10 plus 14 plus 8. They add to 16 plus 14, 30 and 38. And the total has to be 50. So you do 50 minus 38. So it means this one has to be 12. And now you can calculate this by adding them all to 100, adding the 12, 20, 28 and 16 to 100. But we also know that this is just a double of that. So you can do this as 24. And that finishes the chapter.